Hi and welcome to Kaelin-Tech, and today we're going to do a lesson on MPLS Layer 3 VPNs. We're going to do a very quick presentation first before we go ahead and start the configurations, because there's a couple of things that you need to know about. So let's do a quick introduction. So we're going to have a quick look at this diagram. So we've got our provider edge, site A, site B, site B. We've got Bristol, site A, site B, London, site A, site B. Now, as you can see, both customers are using the same private IP address space. So how can we get around this issue of normal routing? Well, we can use VRFs. That's one thing we can do. And you're probably thinking, well, why don't we just do that? Well, there's a problem with that. The first is, this is just a small topology. It's unlikely that an ISP is just going to have a provider edge, and one P router. Okay, so what we'd have to do is we'd have to configure the VRF across the provider edges and the P router for each customer. Okay, that's a lot of work. Brings us a second problem though. What if London are using OSPF and Bristol are using eIGRP? We'd have to configure OSPF across the provider edge, P router, provider edge, and the eIGRP, provider edge, P router, provider edge. We can't really do that for every single customer. It's a lot of work, it's a lot of overhead, it's a lot of man hours, and not only that, you've got to think of the CPU and RAM that would be utilised for this within the ISP network, and it would make it pretty slow after a while once the customer base starts building. So one of the ways we can get around that is we can use multi-protocol BGP between the PE routers. Okay, quick explanation of how it works. One of the C routers advertises something to the PE router using OSPF, eIGRP, BGP, or even static routing. That's down to the customer, obviously. The PE router will then use a VRF for that customer, so any routes it learns will be stored in the VRF routing table for the customer. As we know, we have separate routing tables for VRFs. The PE router will then redistribute everything into BGP, and the PE router will advertise to the other PE router through eBGP. Brings us up the interesting problem, though, of the fact that they're both using the same private address space. So what that actually means is that when London site A PE router advertises 192.168.1.0/24 to the London site B PE router, the other side will learn the 192.168.1.04/24 network, but it has no clue as to what customer it will belong to. So there's no actual way to differentiate if something belongs to London customer or Bristol. Okay, so what we do here is that we have to make sure that the prefixes that are learnt are unique. Okay, so that brings us on to the topic of route distinguishers and route targets. Okay, so let's deal with route distinguishers first. Okay, so we're going to add 64 bits to the 32-bit IP address to make it what we would call a VPN v4 route, which is a 96-bit address, if you like. So the route distinguisher is an 8-byte 64-bit field. Theoretically, you can use any value you want for the route distinguisher. However, as a rule of thumb, use the following format: ASN:(NN). So ASN is the ISP's autonomous system number, and NN is a number you can pick to identify the site of the customer. What's important here is that you make that number intuitive, or if not intuitive, make sure that you document it. You can even do that within the configuration work, obviously, but you'll still want documentation of which NN number that you choose belongs to which customer. Okay, so here we go. So we end up with a 96-bit RD, if you like, because it's the route distinguisher and the IPv4 prefix. So it's the VPN v4 route is 96 bits in length. Okay, So the RD and the prefix combined are known as a VPN v4 route. So let's say that the provider's ASN is 123 and London's customer ID we decided on for site A was 10 and from Bristol's it was 20. We would end up with the following VPN v4 routes. So London, site A, we'd end up with 123. Remember up here we said the provider's ASN is 123 colon 10 because we've chosen the NN number to be 10 colon and then the network that we want to advertise. Okay, and we end up with a VPN v4 route. For Bristol, you notice now it's 123.20. Okay, not 10. So that has now given a unique ID for each of the networks. Okay, so to advertise these routes, again, like I've said, BGP. It supports IPv4 unicast, multicast, IPv6 unicast, multicast, and VPN v4. And what does it use to exchange VPN v4 routes? It uses NLRI, which is network layer reachability information, and that has the following attributes: the route distinguisher, the IPv4 prefix, the next hop, and the VPN label. Okay, so now we're going to move on to the route target. So when the Bristol customer site B P router receives the VPN4 routes, how does it know what to do with them? So what we're going to do is we're going to quickly run through the process. So this is at site B's end, and we've got the provider edge. Here's the route coming in from London, the 123 colon 10 colon, and then the network, and the Bristol 123 colon 20 colon, then the network. Okay. So the PE router at site B has learned the two VPN v4 routes, one for each customer. Because the PE router will not automatically export those routes into the correct customer VRF, we have to use a route target to decide which VRF we import export VPN v4 routes. Okay, so we have to ensure that these routes go to the correct customer. So the route target is also an 8-byte value. It uses the same format as the route distinguisher. Okay, so the ASN, the autonomous system number of the ISP, and the NN number, which is a number you choose again. It's advertised between PE routers by using a BGP extended community value, and we'll go through that when we do the configuration. So for each VRF that we configure, we tell it what route targets we want to import and export. Let's use London customer to explain this. Okay, so we're just using one side at the moment of the London customer. Now, what we're going to do is we'll also include this diagram on the next slide so that we can go through it properly, but it's pretty self-explanatory what happens here. Okay, so here we have the diagram again. Okay, and we're going to explain it now. So both PE routers are configured to use a VRF called London Customer. Okay, so that's the PE routers. When site A PE router receives a prefix from site A London, it will add RD, which is the route distinguisher, 123 colon 10. Remember, we called it that. We said we're going to call it 123 colon 10 to it to create a unique VPN v4 route. Okay. Site APE is configured to add a route target of 123 colon 1 to all VPN v4 routes for VRF London customer. Site APE will advertise the VPN v4 route to site B PE router. Site B PE router is configured to export all VPN v4 routes that uses RT route target 123 colon 1 into VRF London customer. Okay, when site B PE router receives the VPN4 route, it will redistribute it into the VRF so that site B London router learns the prefix. Okay, so an important note here is, as I've put here, under normal circumstances, we would probably use the same route target as the route distinguisher. So you're probably wondering why I've used 123:1 for London as a route target instead of :10, which is the route distinguisher. Well, I'm doing this just to show the difference. All right, so it's to emphasize the differences. That's all. But in the real world, you're better off using the same route target as route distinguisher. So the other issue is that the RD, the route distinguisher and the route target resolve that actual prefix issue of, utilizing the same prefix basically at both customer sites. But it only resolves it at the control plane level. However, we do still have an issue at the data plane level, and we'll discuss that in the next slides. So we're going to go ahead and do that now, and it's the last part before we start the configuration, because it was important that you understood this. Okay, so the transport and VPN label. So as mentioned in the previous slide, we resolved the control plane issue. Now we're going to have a look at the data plane issue and the resolution. So let's have a quick look at this diagram. Okay. And in the above example, the C1 router, okay, is sending an IP packet with the source address of 192.168.1.1 and destination 192.168.2.2 to PE1 router. So it's advertising that, as you can see here, look, it's advertising this from here to the PE1 router. Okay, the PE1 router will add a transport label to the IP packet, and the MPLS packet will be label switched all the way to P3 here, okay, which pops the label, and that's penultimate hop popping, okay, so that the PE2 receives the IP packet, because there's no point PE2 receiving an actual label because it's not going to be MPLS here. It needs it as a normal IP packet. Of course, we could have the label popped here, but the problem is the amount of administrative work that would be on the PE2 router. So we always do it at the router before, hence it's called penultimate hop popping. In the header of this IP packet, okay, there's nothing that will help PE2 decide where to forward it to. To fix this problem, we add a second label called the VPN label. Besides the route target, the PE1 router will also advertise a VPN label to the PE2 router. On the next slide, we'll add one last diagram to show this and also an explanation. Okay, so here's what happens. The C1 router sends an IP packet to the PE1 router. So from there to there, the PE1 router will first add a VPN label to the IP packet. In this example, we use 21. The PE1 router also adds a transport label to it, and it will be forwarded to the P1 router. The packet makes it to the P3 router, which pops the transport label. PE2 sees VPN label 21 and knows that this belongs to the route target of the VRF that connects to CE3. It pops the label and forwards the IP packet to CE3. Okay, that's how that works, and that's the end of the slideshow. Now we're going to get on with the configuration work. Okay, so firstly, let's have a quick look at the topology that we're going to be utilizing. Okay, now what I'm going to do is, because people have asked for me to do an OSPF layer 3 as well, an OSPF for the connectivity. So we're going to have London at the top, site A, site B, and it's going to be OSPF connectivity between the CE and the PE. And for Bristol at the bottom, it's going to be BGP connectivity. So what we'll do is you can pause it here and have a look at this topology. Okay, so what we'll do is we'll start with Bristol customer site A router, and we'll start configuring that first. So let's get on with the configuration. So here we are. Let's have a quick look at the config. to show you that it's just a very basic configuration on there. There's nothing else there at the moment. Okay, so we have the very basics, you know, the normal login class, login user, and SSH. G001 is what connects to the provider edge in Site A, and we've got a loopback address that we're going to advertise into BGP. So let's go ahead and configure this. So the first thing we need to do is we need to set our ASN number. So we do that in routing options and autonomous system, and we're going to put this at 65100. Next, we need to set our group. So we set protocols, BGP group, and we're going to call it site-a-pe. I know normally we don't use capitals, but I'm doing this to emphasize what site we're on. Okay, and the type is going to be external because we're using eBGP here to connect to the provider edge. Okay, so we'll use the up arrow, and we need the peer AS in here. So let's put in the peer AS that we know is 65533. Okay, we also need to put in our neighbor address, and we're going to go to the physical interface, not the loopback. So we'll put in here neighbor 20.20.20.1, and that's our PE address that is the peer to this address. Okay, now we're going to set our policy options and our policy statement. Okay, and we're going to call this, let's just call this to site A-PE, and we're going to put our term on there, and we're going to call it term 1. And what protocol do we want it from? Well, it's directly connected to loopback, so we want it from protocol direct. And then all we need to do is to accept that. So then we accept that. Okay, and what we need to do now is we now need to do set protocols BGP group. Okay, and we called it site APE, and we need to export. So in other words, we need to export out to the provider edge are directly connected. In other words, our loopback. Okay, so we called it to site APE. Okay, so let's commit that. Let's have a quick look at the configuration. Oh. So that's all in there. That's actually the basic configuration. It'll probably be a lot bigger than that in an actual live environment. In fact, it will be a lot bigger than that. So before we actually configure up the provider edges, as they're going to be the biggest set of configuration that we need to do, let's do our P routers in the middle. If you remember, we've got 2 P routers. Okay, we've got P router 1 and P router 2. Okay, and we are going to configure those up now, but we'll have a quick look at the configuration on them first. So let's go to P router 1. Okay, let's log in. So we're logged in. Let's have a quick look at the configuration. Now we're utilizing is as the IGP in the provider network. So we have, as always, our login class, login user, SSH. Our interface is G004 and 5, and they connect. 5 connects to the provider edge, and 4 connects to the secondary P router 2. Okay, we've got our ISO address on the loopback. We've got our loopback address configured, and we've got is configured. So we now need to configure this with MPLS and LDP. LDP being dynamic, so you can have a look at the difference between LDP and RSVP. So let's go into edit mode, and we are going to set both our interfaces. We are going to set these into the family MPLS. Okay, we need to ensure they're in a MPLS, and we also need to put 5 in there as well, and we can commit that. So that's one part of it done. Okay, now what we need to do is we need to do our protocols MPLS and LDP, and it's quite simple. So let's do set protocols MPLS interface GE-004.0 and 5.0, and we also need to do our LDP. So set protocols LDP interface GE-004.0 and 5.0, and we can commit that. And that is all we need to do currently on our P router for this basic configuration. So that sets up our label distribution protocol on both those interfaces so that we can have label swapping processes happening. Okay, now we need to do the same on P router 2. So let's log into this one. And the configuration is going to be almost the same. So let's have a look at what's on there currently. And it will be the same as P router 1. So again, login class, login user, services SSH, G004 and 5. They got the family ISO there because again, it's is. We've got our loopback address here, and we've got our net address here, and we've got our is protocols configured. So let's go ahead and configure this section. So we need set interfaces G-004 unit 0 family MPLS, and we need that with 5 as well. Okay, now all we need to do, the same as the others, we need to set our protocols again. Set protocols MPLS and put those interfaces in it. G-004.0 and 5.0. Okay, and we also need to do LDP and put the interfaces in there as well. And 5.0. And we can commit that, and that's those two configured. Right, okay. Now what we're going to do is we're going to move on to, and we'll start with the provider edge at site A. So we are now going to be looking at this router here. Okay, the provider edge on site A. So let's go ahead and have a look at what we've already got configured on there. So we've got our login class, our login user, our SSH, our interfaces. So we've got one out to London, the one to Bristol that we're working with currently, and the one that goes to the first P router. Okay, now what's important to note here is that obviously anything that's ISP related only sits on ISP facing interfaces. So we only have ISO. So in other words, we'll only have is on G005. We certainly won't have it on 0 or 1 because those are the interfaces that face the customer. Okay, so we only have them on the internal facing interfaces, what we require. We have our loopback, and we have our net address, and we have our is. So let's go ahead and complete the configuration that we require on here. Okay, so let's go into edit. Now, the first thing we need to do is we need to set our autonomous system number because we're using BGP for this connection. Okay, so let's put that in first, and it's 65533. Okay, we'll commit that for now, because what we've got is we've got two BGP parts that we need to do. We have the iBGP, which is always required anyway between the provider edges. That provides the MPBGP for us, the multi-protocol. Okay, and we've got a routing instance, BGP. So what we're going to do first is we'll get that up and running. So we'll set our VRF, which is what's required, a separate VRF for each customer that we have. Okay, so we're going to do routing instance. Okay, and we're going to call it, let's just call it Bristol-Cust A. Okay, and the instance type is going to be VRF, surprise, surprise. Now we can use the up arrow here. Okay, and what we're going to do next is we are going to put in there the interface that faces the customer. Okay, in this case it's GE-001.0. That's what faces Bristol. Okay, now we come to our sections that I described in the presentation of the route distinguisher and route target. So let's put in here our route distinguisher. Now, in the presentation, I said that the AS is normally used, but actually what people use is they use either the AS or the loopback address of the provider edge router that they happen to be on. So we're going to use the AS number. So we are going to call it 65533. And if you remember in our presentation, we said we would use 10 for the NN number. For Bristol and 20, no, we said 10 for London and 20 for Bristol. So we're going to put 20 in here. Okay, that's what will create our VPN v4 96-bit address. Okay, so the IP, so this will be prepended to the IP address as it's forwarded. We also need to put in our VRF target. Okay, and the way we do that, what we're saying is, what's the target at the far end? You know, we need the VRF and we need the target of that VRF. Very important that this is the same at both ends. Okay, all right, so what we're going to do on here is we're going to put a VRF target. Okay, there's obviously a few there. So our VRF target, and we have to label it first with target, colon. Then again, as we stated in the presentation, we'll use the same ASN NN number. So we'll put in there 20. Okay, that's that section completed. Now we actually do our BGP group itself. Okay, so we have our all the way back to our routing instance, and we put in there our protocols. Okay, BGP and our group, and we'll call this to Bristol, I don't know, Cust A. There we go. And the type is external. So this has to be done within the routing instance, okay, within the VRF. And the peer AS, as we know, is 65100. And we need the neighbor. And the neighbor address in this case is going to be 20.20.20.2. Okay, so we can commit check that first, but it should be fine. Spacebar playing up. So we're going to commit that. And what we'll do is we'll have a quick look, run show BGP summary. Okay, and we're already established. Okay, it already sees that we are going to be expecting some form of VPN coming in. okay, because we have the INET there already. So we have the forwarding. This is going to be its own forwarding information base, if you like, okay, and it's in an established state at the moment, which is good. That's exactly what we want. Now what we can do is we can configure up our internal BGP, but it won't obviously be functional just yet because we haven't configured the far end. So let's go ahead and configure that anyway. So we're going to do set protocols, BGP group, and we'll call this, as we always do, internal peers, and the type is internal. Okay, we also need here, we need to put our local address that we want to utilize, and our local address is going to be the loopback, so it's going to be 4444. Okay, that's our local address. We also need to tell it that we're going to be pushing across here VPNs. So we want to put in there family, INET, VPN, and we're going to put any. In fact, I'll just show you quickly the options you've got. So you can have unicast. We could put unicast here if we wanted to, but we're actually going to put any. Okay, just to cover everything at the moment. And then our neighbor address is going to be the loopback address of the site B provider edge. Okay, so we need to put here, and that's going to be 5.5.5.5. Okay, and we can commit that. Now let's have a quick look again at our run show BGP summary, and we should see this as active. Okay, and it won't change from active at the moment until we actually configure the site B provider edge, which we're just about to do anyway. So so we'll go ahead and do that, and you'll then see this come up as established as well. Okay, as you can see, we're already receiving, so 1 active, 2 received, 2 accepted, routing in that routing table. Okay, the forwarding information base for this VRF. So let's go to site B, provider edge site B, and let's show you the config again here. Okay, so as per the other side, we've got login class, login user, SSH. Again, the customer interfaces are both here, and our internal interface, as per the other side, is the only one with family ISO. We have a loopback address configured, an ISO address, and the is. Okay, so let's go ahead and configure this. Now on this one, we can actually actually, I may have missed one piece of configuration on here. Let me just have a look, and you might be able to tell me what it is that you think I may have missed. So let's have a look at configuration, interfaces, display set. Yep, so if we go back to our diagram, G005 belongs to this internal network. So this is actually not going to work at the moment, okay, unless we configure up the following. And we don't have it on here. This is just to let you know that we've missed this, and we're going to put it in. So let's do set interfaces G-005, okay, unit 0 family MPLS, so we need to put that in. We then need to do the set protocols, MPLS interface G-005.0, and set protocols LDP interface G-005.0. Okay, let's commit that. Let's do a quick run. Show configuration display set. Okay, we have our LDP and we have our MPLS, or MPLS and LDP. That's good. And we have our interface in MPLS. That's good as well. So on here, we'll start with that to ensure we don't miss that piece. Set interfaces G-005 unit 0 family MPLS. Set protocols MPLS interface G-005.0 and set protocols LDP interface G-005.0. Remember that we don't need to put any customer facing interfaces into any of this because it's internal for the ISP only. Okay, so what we're going to have a look at now is we're going to now configure up our internal and make sure that gets up and running first, as we've done the other end. So we'll do set routing options, and we obviously have to give our autonomous system number, which is 65533. Okay, then we'll do set protocols BGP group. Again, we'll call it internal dash peers, and the type is internal. Okay, now we can use the up arrow, and we need to give it our local address again because this is the internal. So our local address is going to be 5.5.5.5 on this one. Okay, we also need to tell it the family VPN because we're going to be pushing VPNs across this. And we're going to give it an NE as we did at the other end, and we need to give our neighbor address. Okay, so let's put our neighbor address in there of 4.4.4.4, and let's commit that, and let's do a show run show BGP summary. Okay, it's active at the moment. Connect, open sent, open confirm, established. Okay, and that's the order that you'll always see BGP do it in anyway. Okay, so you notice we've got everything is starting to be set up now for our forwarding information bases again, databases for the VPNs. Okay, so that's that section configured. Now what we're going to do is we're going to move on and we're going to have a look at Bristol customer B. And let's have a look at the configuration. Okay, so what we need to do now is we need to configure up Bristol site B, and again it's very simple. So let's do an edit. We're going to set the routing options, our autonomous system number, which on this particular side is going to be site B is going to be 65101. Okay, we need to now set up our group, so we'll do set protocols BGP group, and we're going to call this one site dash B dash PE, and it's obviously external. Okay, so we can go up and we can put in there our peer AS, and our peer AS is 65533 as we know, and we have to put in our neighbor address, and our neighbor address is going to be 40.40.40.1. Okay, then we're going to set our policies to advertise our connected or our directs. So our policy statement So our policy statement, which we'll call to site B PE, and again, term 1 from protocol direct. Okay, and then we need to accept that from term 1. So we do a then accept. Okay, so we're going to accept that, and then what we're going to do is we need to export that. So we're going to do set protocols BGP group to site PE, and we're going to export to. Okay, now we can commit that, and that is the configuration for Bristol customer B, so site B. So now we can go back to the provider edge and we can configure our VRF. Okay, so let's configure that up. So we'll do set routing instances, and we're going to call it Bristol-cust B, and the instance type is going to be a VRF. Okay, we need to put our interface in there. So we need to put interface G-001.0. We need to put our route distinguishers. Okay, which, if you remember, we said was 65533:20, and our VRF route target. So let's pop that in. Okay, and we're going to give it the same. Remember, it has to be exactly the same. So target 65533:20. And when I say exactly the same as the far end PE. Doesn't have to be the same as the distinguisher. Just helps if it is from a troubleshooting perspective. Okay, so now we have to set up our group. So we're going to put in here protocols, BGP group, and we're going to call this to Bristol-cust B, and the type is external. Okay, and we need the peer AS, and the peer AS is 65101, and we need the neighbor address. Okay, so our neighbor in this case is going to be 40.40.40.2, and we can commit that. Our VRF target we did configure, didn't we? No, obviously not. My apologies. I thought we had configured the target. Okay, so set. Routing instances. There you go. There's a good bit of troubleshooting there. Bristol customer B VRF dash target, and the target is going to be 65533:20. Let's do a quick commit check this time. There we go. I could have sworn we did that because I spoke about it with you, but it's done now. It's completed now. So let's do a quick run, show configuration, display, set. Okay, so that's all there. So let's do a run, show BGP summary. Okay, and they're both established now. And as you can see, we have all the routing there. We have the ribs. So let's do a run, show route, run, show route. And let's just confirm. So we have our is. We have our INET 3 destinations. Okay, and our LDPs. Okay, they'll always sit in INET 3. Then we've got our routing tables for our instances. Okay, so here's our BGP routes. Okay, we know that at one end is 333 and the other end is 9999. Okay, so if we go back to our diagram, so here, loopback at site A is 3333 and the loopback at the site B is 9999. And I purposely made it the same on both, if you remember, and we've configured nothing on this side yet. So there's all our LDP and layer 3 VPN information. So let's go to Bristol customer B and run show route. Okay, and within there we now have from BGP, which will be across the layer 3 VPN, we have the connectivity to site A. So can we ping it? Run ping 3.3.3.3. Yes, we can. Okay, now if we were to complete a trace route across there, we will, of course, from the perspective of the middle P routers, we will probably just get stars, but we should see the popped label at the far end to show that it's going across the layer 3 VPN. And we know it is anyway because the middle routers will not see those particular routes. Okay, so run trace route 3.3.3.3. Okay, so let's have a look and see what we get. Remember, in the middle two sections, we're likely to see stars, so it may take a few seconds. So that's our first P router, second P router. Far end of 192.168.1.1, and as you can see, there's an MPLS label associated to that with the TTL. There's no class of service anyway, but that's the label being popped, or the outer label of 299952. Okay, so that's going across the VPN. Now that's how we can configure a BGP VPN. Now the tricky one that a lot of people have problems with is anything that's not BGP related between a CE and a PE. Okay, so on the London side, right? Okay, so let's log on to London, and this is going to be an OSPF configuration for those of you that wanted to see an OSPF one. So first of all, let's have a look and see what we've got on there to show you there's not a lot on there, not really. So there's just the usual login class, login user, SSH, interface that faces the provider edge, and a loopback address. So let's go to edit. And obviously we want to utilize OSPF here. So in this instance, routing options, we're going to put in a router ID. And we'll use the loopback address. So we'll put 3.3.3.3. Okay. That's our router ID configured, and then it's just obviously very basic set protocols, OSPF area. Oh, sorry, I've pressed the wrong caps lock. Protocols, OSPF area 0000, interface GE-000.0, and we want the loopback in there as passive, as always. Passive, again, in case you've forgotten, meaning that it will advertise the network, but it won't participate in any LSAs or anything like that. Okay, so that's it. That is the configuration from the perspective of an OSPF CE to PE. Okay, so it's when we get to the PE that it becomes a little bit more interesting and a little bit trickier. Okay, because we're utilizing OSPF. Okay, so one of the things that we do need to do is we need to put in a secondary loopback interface. Now, as always, with Juniper, you can't just simply create one. It will only allow you to do it if you do it in a separate instance. So what we'll do is we're going to set up our instance first. Okay, so let's do our set, our routing instances. Okay, and this time we're going to call it London-cust A, and the instance type is going to be VRF. Okay, the interface that faces it as per what we always have to do. So let's put in there our interface, which is GE-000.0. Okay, our route distinguisher, which in this case is going to be 65533:10, not 20. Then we have to put in our target. So we'll put in our VRF target, and we're going to call that target : 65533:10. Okay, that is our target configured. And we also now have to do our protocols. Okay, so let's put in here our protocols. So we're going to put in there protocols, and we know it's OSPF. OSPF area. We know it has to be 0000, and our interface of GE-000.0. And we're going to enter that, and we're going to commit that. Okay, and from here we're going to have a look at run show route 3.3.3.3. Okay, that's because we've got the same at each end. So in other words, what I mean is because we've also got 3.3.3.3 on the Bristol, and that's where it's seeing that. It's seeing that in the Bristol database currently at the moment. Now, that's purely because there are some bits and pieces that we need to ensure are configured correctly here. So one of the first things we're going to do is we're going to go across to site B, and we're going to configure it up exactly the same. Okay, so again, show you the configuration, and to show you there's not really anything on there. Okay, so let's do our set routing options, router ID, and in this case it is 9.9.9.9. Okay, let's set protocols OSPF area 0000, and in there we are going to pop our interfaces G-000.0 and LO0.0, and it's going to be passive. Okay, that's our configuration there completed. Okay, what we need to do now is on this particular system, we need to do exactly the same thing as we did on the other side. So we're now going to set our routing instance. So set, sorry, that's on the customer. The customer's finished with now. It's the PE that we're doing this on. So set routing instances, and we're going to call this one London-cust B, and the instance type is VRF. Then we need our interface. So we go back to there and we'll do it. Okay, we also need our route distinguisher. So we're going to put in there a route distinguisher, and again 65533:10. Okay, and our target So our VRF target at the far end is going to be target colon 65533 colon 10. Okay, and we need to do our protocols again. So set routing, we'll just use the up arrow. Going to be a little bit quicker. So protocols, OSPF, area 000, interface, and the one that's facing the customer is 000.0. Okay, so let's commit that. Now, we have that committed, and that's what you would think is exactly the same as what we did with BGP, okay, except we don't have to do the extra configs because it's not BGP, it's OSPF. So let's have a quick look then. If that's the case, let's have a look at the London customer and let's have a look at their route. Okay, so what route is missing in there if that is all the configuration we should need to do as per the BGP side? Okay. Well, the problem we've got is that we're not seeing the 3333. So if we go to the London customer A, we should see the 9999. But of course we don't. We only see the local directly connected. Now there's a reason for that. And one of the reasons is that on the PE, we only see it as an IPv4 route. Okay, we do not see it as a VPN4 route. So what we have to do is we have to create, for a layer 3 VPN with OSPF on there, we have to create a sham link between the two sites. We can only do that if they're both in the same area, which they should be anyway. So we're using area 0 at customer B, at site B and site A. So let's start with site A and complete this. And remember, loopback wise, we can only have the one within one instance. So we have to set the loopback in the instance first before we can configure it. So let's do a set routing instances, and it's our London customer A and an interface of LO0.1. Okay, now let's do set interfaces LO0 unit 1. Okay, and we'll put a description on there. Sham link test. Okay, this is what allows us to extend across a layer 3 VPN and OSPF connection between a CE and a PE. Okay, so we'll call it a test, and let's give it a, I don't know, let's do this end. Let's give it a family INET address 100.100.100.100/32. Okay, so we'll go ahead and commit check that a minute. Okay, and that's fine. So let's commit that. All right, now we have to do an extra bit of configuration within the actual routing instance itself. It's quite a simple piece of configuration. So we're going to do a set routing instances, London customer A, and the protocols, OSPF. And this time, let's have a look at what options we have. Okay, we have quite a lot there that we can utilize, but we want to utilize this one because we're configuring a sham link. So we're going to put in there a sham link, and we have to put our local address first. And what's our local address? Well, our local address is 100.100.100.100. It's the loopback we have just configured. Okay, so now we can go back to there and we can say protocols, OSPF. Now we have to do our area 0000, and we put in a sham link remote. Okay, so what's the remote address we're going to use? Well, I'll tell you what, let's configure up on the other PE a secondary loopback and give it 200.200.200.200. Okay, that's the address we'll give it the far end. So let's commit that. So that's been committed from this end. Okay, so that's site A committed. So what we're going to do is we're also going to now have a look at site B, and we're going to do the same but the opposite way round, obviously. So let's do our set routing instances, and we're going to call it we're not going to call it, it is that anyway. And we want to put in there our interface of LO0.1. Okay, and then we're going to do set interfaces LO0 unit 1 description sham link test, and we'll give it an address. So family INET address, and remember we said we're going to do 200, 200, 200, 200, and we'll commit that. Then we need to do our set, because we need to do it within the instance now as well, the routing instance. Routing instance is London, so that's customer B, London cus B, and the protocols, OSPF, the sham link, if you remember, the local address first, and here it's 200.200.200.200. Okay, and then we have to put in our area. Okay, 0000. Remember, for a sham link, it must be the same area at both ends. And a sham link, what's the remote address? 100.100.100.100. Okay. We could put on there a metric of 1 as well, but we should be okay with just putting this on there. If not, we'll put a metric of 1 on as well. Okay, so we're going to commit that. And what we're going to do now is we'll go to London customer B. Remember, we didn't have 3333 in there. Now, it might take a few moments for OSPF to reconverge and update that information. So let's have a look now. Run show route. Okay, and now we have showing up 3333. Okay, can we ping it? Run ping 3.3.3.3. Yes, we can. Whereas before we couldn't. So we know, because this is OSPF and we have no BGP configured, we know that we are now connecting to London. We are not connecting to Bristol at all, okay, with regards from London configuration perspective. And again, if we were to do a run trace route 3.3.3.3, we should see the same, where we'll see the stars for the P routers and the far end and the label. So there's our first P router. Second P router and our endpoint with our label. Okay, and that shows the BGP configuration from a CE to a PE and an OSPF. So a customer that may be running OSPF and a customer that may well be running BGP. Okay, those are the two main ones. You won't normally have people wanting to do static or I would think, unless they're a pure Cisco site, it's unlikely they'll want to do eIGRP. Is also unlikely from a customer perspective. Is normally just utilised internally by ISPs. But if you have any questions regarding this lesson, then please let me know. Okay, I hope you enjoyed that lesson. Thank you. Bye-bye.